Hello world, how are you tonight? Welcome to Building a Roguelike in C, the stream where we are constructing a classic ASCII roguelike in standard C using a limited number of libraries. Most of the libraries we will craft ourselves, and no frameworks or engines that are pre-built. So, the last stream, we built our simple dungeon generator, and let me quickly show you what that looks like. Probably should have had this ready. Let's see. There we go. Okay. So there's our game screen, and we generated a random map. We carved out the different rooms using our room generation algorithm, and then we drew some corridors between them in horizontal and vertical lines, and ended up with something like this. And we can run it every time. It'll generate different dungeon layout. So tonight, I'm thinking that I'm going to want to formalize the initialization of a dungeon level and have it be something that is easily callable. So I think that's probably what we'll get started on. Close up our game and get us ready to go. Okay, so let's jump in. And right now, we can kind of get rid of some of this stuff. This was some debug code that we no longer need. Our initial walls in. And right now we just have this right before we enter our main game loop. We're calling map generate, and then we're actually adding entities for every single wall in our system. And so what I'd like to do is I'd like to pull that out into a separate function. When we do that, I want to check wall add is in. So let's do split screen mode, and then if I remember my key commands, yes, okay. Still training the muscle memory with the Windows version of Sublime Text. I'm used to Mac, and the key codes or key bindings are all different. Sorry about that. Okay, so what we're going to do is we will add a function over here. Map generate, and so maybe we'll have a something that will be like initialize level. I'm just thinking about how I want to organize this before I go ahead and start throwing stuff together. So I think once we have our generation stuff and our level generation code in a working order, then we'll come back one evening and just spend a whole evening just moving stuff around and refactoring and probably breaking it into separate files of related functions, just because there's going to be stuff that we'll want to reuse in other games and stuff that is specific to this game, and we'll take the reusable items and put them in the beginnings of a library file. But that's not an effort for tonight. So here's our game object management. I don't want to put that in the middle here. Perhaps we'll create a new level management section. And we'll have a level init. And we may or may not take parameters. I guess we'll figure out what it is that we want to do with it. So what do we want this level init to do? We definitely want this map generate stuff in here, and the adding of wall entities into our world state. But what we'd also like to do, so step one, generate a level map into the world state. So that's step one. And then step two, at least for now, is place the player in a random room within the level. Hey, Mr. Love Pickle. Hey, it's good to see you. How's it going? Glad you could join me tonight. I don't think I ever asked you, do you do programming yourself? Alright, so we're going to place the player in a random room within the level. But this is interesting. This brings up an interesting question about our world state, and is when we move from one level to the next, do we kind of reboot world state? Hey, Game Dev 513, how's it going? Mr. Love, Ruby developer, did you catch any of the Twitch programming streams this last Sunday? It was like Ruby Day. Ruby Day all day. And so I'm going to punt on that decision for a little bit, whether we wipe world state or not. We're not going to wipe the entire world state, so we'll probably have a certain collection of entities that are maybe tied to a level that we would clean. Oh yeah, you can probably still catch. I don't know that there's that they introduced the Twitch programming channel last. Maybe it's been 2 weeks ago now. I think it was 2 weeks ago, and they've had various scheduled programming throughout that time. And this past Sunday was all about Ruby, and so they had, I think a lot of the stuff was pre-recorded. They played some convention talks from previous Ruby comps and all that, but yeah, it was all day Ruby streaming on Twitch/programming. So it was pretty cool. I'm waiting for them to do C Day, which I think I'll be waiting a while for that, but you can hope. Okay, so this, we're creating our player here. We have our world state init, and we can create our player here, and then call level init, and perhaps pass it perhaps we can pass it our player, and it will adjust the position component for our player. So we can say we're going to give it a game object, and that will be that'll correspond to our player. Passing player here, and the expectation is that the player will be positioned within the level that we have just initialized. Yeah, I hear you. I do a lot of mobile development for my day job, and I'm at the point now where it's good to keep that at the day job, but I want to do something else for fun. And so that's kind of the reason for this project, diving back down to the lower levels of the machine, and kind of implementing or re-implementing a lot of algorithms that have been buried in my brain for, I haven't dug up since college. So I have on my to-do list, we're going to need it pretty soon when we overhaul our entity component system, implement a classic linked list data structure. And we're going to do it so that we can have a generic list object in C. And that will probably we'll probably code that sooner rather than later, but not tonight. All right, so if we call level init here, we'll create a level, put our player in it. Right now, we're just writing a random. I think we can remove, or at least comment this out for now, this position code, because we're just setting them to an arbitrary value at this point. So we'll just create our player. We'll give our player visibility and physicality, but we will not position our player. We'll leave that up to level init. So we can take that over here. And we'll pull that. Within the level. Now, of course, we don't want to position it at 2525. We'd like to place the player in a random room within the level. So, map generate. We don't have our room structure anymore. We don't. We throw those away. Ah, bummer. Map generate. I was originally thinking that I would loop through the rooms that we have and then pick one of those at random and then pick a random spot in that room. But maybe it would be interesting if we just placed them. They didn't necessarily have to be in a room. We could put them in the corridor. And so what we would do in that case, we have our map cells right here, which is it's essentially a bit field. It's a bunch of bools, a grid of bools that indicate one value for each cell in our map. And if the value is true, then that cell is a wall, and if it's false, then it's open space, be it a corridor or a room. So what we could do is we could just keep trying to drop our player until we hit an open spot. So let's do that. We'll just have a we don't need this. We don't need a bool. We can just do this. Say loop forever until we break out of that loop. So we will find our random x, which is a random value between 0 and our map width. And then we have our y, which is a random value between 0 and our map height. And so what we'll do is we'll check and say if, what is it, map cells. In this case, we're looking for false, which indicates that there's nothing in the spot. If that is the case, then we found a valid position for our hero. And we can drop him in there, or her. Equal opportunity heroes here. We will place our, generate a position component, and we will add that position component to our player. And once we've done that, we break out of the loop. Yes, I think so. And yeah, I think that's good for now. I can see us adding to this function in the future, but I think this is good for now. Let's check things out and see what we've got. Compiling, it's half the battle. Okay, so this placed it correctly in the middle of a room. Guess we can try it a couple times. Maybe I should add a quick... Let's do that. Okay, he's in the middle of a room again. So that we can facilitate a little testing, let's do some... Oh, and we can get rid of this now, because... Let's add a key binding right now that just generates a new level for us. Because I don't want to have to keep restarting the app. We'll put it right at the top because it's a debug thing. We'll wrap it in a... We'll add a case. It's probably SDLK. I'm gonna, let's see, what do we want to do? M for map, temporarily. And what we want to do is call, I think if we just call level init. Send in our player. That should be okay. And we aren't concerned with, we are at generating a new position here, but we are not concerned with we're not concerned with generating like let's see. We have add component. We take the component data. I just want to make sure that we're not going to be leaking memory like a sieve here. Always need to make sure you're cleaning up your stuff. So player, this is created on the stack. Okay, we're creating it on the stack, so we're okay. Position, we're passing it in by reference into add component. Add component then copies. Is there a way? Sweet. What's the, I need to bind that to something. Add component copies the data into the existing position. So it's not like we're pointing to a new thing and abandoning the old object. It's the no memory is lost. So I think we're okay. Oh, and I just realized you guys can't see that. Sorry about that. Okay, undeclared. So my M key is not what I'm thinking. Let me look it up real quick. And that will give me another opportunity to show you the glorious SDL2 wiki. Okay. And so in this case, I'll usually look them up by category. And we've got input events, keyboard support, scan code values. Is this the... Yes, okay, so this SDL key code value is what we're looking for. And we want M So it's SDLK small m, not big M. So let's make it small m. Save it up. Okay. All right, now we've got our map, and let's try and generate a new one. M. Well, that is a very interesting map. And I think that the problem is that we are not clearing, we are not resetting our cells. Very interesting. Okay, let's do that. So up, map. Okay, map cells right here. This guy, he's persistent between calls to map init. So in our map generate, we are setting everything to true. What we're not clearing out is our generated walls in our world state. That's what we're not clearing out. So level init needs to do something else. We've got right here our various components. Here's our entity game object. This is our entity component system that we built. We've got our game objects, and each of those objects is made up of different components, or can be made up of different components. Right now we only have 3: position, visibility, and physicality. When we add a wall into our world state, we add a wall object, and it has a position, and it has visibility and physicality. And so if we regenerate a new level, we basically want to get rid of all of our previous walls. So, I'm not sure the best way to go about doing that at this point, because how do we tell that something is a wall? I guess we can look at the visibility, but I don't like that.
See your eyes in different faces. It's bugging me out. Sliding and get complacent. It's scaring me now.
Well, one thing we could do, I feel like it's cheating a little bit, is we could basically clear out anything that is not our player or related to our player. Which I guess is okay for now. Is there anything that would uniquely identify a wall? We're just generating a game object and then giving it a position, visibility with the wall glyph, and we're saying that you can't walk through it. You can't walk through it and you can't see through it. Alright, let's So we have a new step 1, which is clear the previous level data from the world state. And so basically we're going to loop through our world state and destroy any object that is not our player. What game max go is that? So it's max game objects. Cool it, pup. And we'll say if not used to using my own routines yet, so let me think. I guess we just match it against. We match our ID and see if it's. We grab the item from the array, from our game objects, look at its ID, see if it's the same as our player. Okay. So we if game objects at index I, and then we look at the ID for it, and if that is equal to our player ID, if it's not equal to our player ID, we want to get rid of it. So we'll say game object destroy, and I don't remember what that takes anymore. It takes a pointer to our game object. Because it essentially, we're not deleting any memory, we're just marking it as unused. Okay. I'll take objects, and we'll send the address of that in there, or reference in. And that should clean up our walls. So we'll give that a go. Oh, we crashed. Okay. Let's double check our code before we rely on the debugger. Okay, we're looping from 0 to our max go. Checking game objects at that game objects is not player ID. Are we passing a player? And then we're just trying the game object at that position. Let me just refresh my memory. We defined a game object. You know what? I wonder if we're not cleaning things up. So, yeah, we've got a problem here. And the problem... No, we're marking them unused. Our position comp. Well, one thing that we're not doing is we're not cleaning up this components array. So it's an array of pointers to components. But I think I remember determining that that was actually okay because we're not referencing that. If we're marking this as unused, let's bust out the debugger. Gonna launch it and see what we can see. Show you guys Visual Studio. So it comes up. My debugger's not even coming up. That's a super fun crash. Nope, here it comes. Alright, let me... Come on, this thing. Okay, there it is. Alright, so it brought us to our game object destroy, and it is complaining right here. So perhaps we sent in... Ah, it's coming in with ID. Well, it's looking for object ID 100,000, which is out of bounds. Did we break our loop? Maybe our loop is off by 1. I should be 0 to less than 100,000. Game objects. Maybe our initialization is wrong. Let's go back to the code for a second. Jump back in here. So somehow we're passing an object with an ID of 100,000 in. So that makes me suspect our world init as being off. ID is unused. Where are we setting game objects ID to 100,000?
When you're too busy chasing the clouds, do you ever think of looking down? Would you find your way home? And I know our love was never easy. And I want
All right, I'm looking back here now. And I jumped into the call stack, and so I is 1. So we're not even at the end of our loop. How is the game object at slot 1 have an ID of 100,000? Which is our... Let's go. I'm gonna... search for this. Oh. Wow, I gotta remember my own conventions. So, 100,000 is our unused value. Here. So we don't have an item. What we've done is we've hit an unused cell. Let's go to level init. So what we also need, we need another clause here. So we need to set another condition. So if it's not our player ID, and it's also not unused, then we want to destroy it. Okay. Stop debugging. So I want to save my changes to a solution. Okay. All right, so now we have our game back. But you can't see that. Okay, now we have our game back, and now I'm going to hit M to regenerate. And that looks way better. Okay, MMM. So now we're properly clearing out the previous level. All of the entities and components that were associated with the walls in the previous level get cleared out, and we can generate a new clean map. Excellent. Everybody with me? Okay. What's next? So we created our level initialization function. We mapped it to a key binding for debugging purposes. I'm going to consult the to-do list. We are placing our hero in there. So the next thing that I want to work on, and this is going to take probably several streams to dial it in because it's not a trivial algorithm. I'm still trying to wrap my head around it, but what we're going to be doing is field of vision or field of view, which is basically determining what our hero can see, how far he can see, and what he can see based on what's around him, what obstacles or obstructions are shielding his line of sight. And also, we're not giving him like infinite distance sight. We want to cap that vision. I mean, you're underground, so your vision is limited, and so we'll consider it like he's holding a torch or she's holding a torch, and casting a certain radius of light around them. So I'm going to tackle this in a couple phases, and the first phase is the simplest, and what we're going to do is, for the initial phase of our field of vision implementation, we're going to make the rule that the hero can see everything that's in the room with them, in the room that they're currently in. So as soon as they enter the room, we'll illuminate that entire room for them. And then conversely, when they leave the room, we'll hide it. And that's definitely suboptimal, but it will give us a useful building block, and it'll get us started down the road. Because I think regardless of what the final implementation of our FOV is, I like the mechanic where you can see everything in the room that you're currently in. So we'll probably keep that code. And then as they're leaving the room, then we'll factor in, well, how far away is something, is it in line of sight, all of that. So we'll blend the two algorithms. And this might call for a new file, because this is definitely something that we would want to reuse for going forward, or this would be something we would break out into a reusable library for roguelikes. So I'm gonna create a new file. Call it fov.c for now. That seems like a good name. And we'll save it so that we can get our syntax highlighting and Sublime text based off of our extension. So let's have a FOV calculate function. And what that'll return, we're gonna need a new structure that will represent our field of vision. And essentially it will be the same as our map is. So it'll be very similar to this guy right here, map cells. Except instead of bools, I think I'm going to have it be an array of ints because I will likely want to work into the algorithm at some point in the future the concept of degree of sight. And so maybe a 0 represents hidden and a 10 represents visible or like fully visible, and then we have degrees of visibility where we can do some things with alpha blending and kind of fade things out that are sort of visible. Or we could do things like have fog. That might be neat to have some kind of fog effect where we do glyphs that are semi-transparent. Yeah, I think that might work. So we don't actually need we just need a we probably just need an array, and we would actually just return that. Or we could have it handed to us and then we would regenerate it. Update all of the... Yeah, let's do that. Yep. We'll take a reference to our FOV map, or the memory allocated for our FOV map, and then we can clear it and then update it based on our new player position, which is, that reminds me, that's the other thing that we're going to need. Hey Drowsy, thanks for the follow. I appreciate it. Glad you could join us. So we're going to need our map, and we're also going to need our X and Y coordinates in the dungeon to be able to calculate that map. So let's, like we've done with other things, let us write the code that's going to use our FOV interface so that we can kind of shape that to be exactly what we want it to be. So the first place that we would call our FOV calculate would be, I guess, immediately after we create our level, right? Okay. And we would pass it. Well, we'll have to dig up our position, and then allocate memory for our map as well. So let's do. First things first, we'll bring in our include. So that we can get at that good code. And next thing, so we need to pull. Oh, we already have our. We're initializing it right here, so we've got our... Oh, we don't have our position. We're not initializing it here anymore. Am I done soon? What ID or text editor I'm using? The second question, I'm using Sublime Text. So I'm using Sublime Text for the actual text editing, and then for debugging purposes, I will throw the code into Visual Studio 2015 to take advantage of the debugger features there. And am I done soon? Are you talking about streaming tonight, or are you talking about like where I am in the game development process? All right, so we need to get our new position component from, call it player pause. And we will game object get component. I think we passed in, we'll verify, I think we pass in our player game object get component. We pass in our game object, a pointer to our game object, and then the component that we're interested in. So we've got our pointer, and then the component we're interested in is a position. And that returns a reference that we will need to cast to, it's a void pointer. So we'll need to cast it to a position pointer. I need to spell position properly or we'll run into issues. Both. So I'm probably almost done with the stream for this evening. I'll probably stream for, a little, I'd like to get a little ways down this FOV calculation. Am I close to finishing the game? I'm on day 7 of developing, and each stream is 1 to 2 hours long, so I'm not very far into it at all yet. That said, the scope of this game is fairly limited, so I expect it to take me several weeks to finish, but I think that the finish line will be it'll be in the order of weeks, not months or years. So again, I'm doing this to refamiliarize myself with C programming, refamiliarize myself with kind of core algorithms and techniques, with the goal being that I will roll that knowledge into another bigger, more ambitious game. But baby steps first. So if you gals think that sounds interesting, give me a follow and we can take the journey together. All right, so we grab the position component from our player, and we're going to pass that. We're going to pass the X and Y. Player pause. X and Y. And then, so the last item we're going to need is our map, which is going to be a two-dimensional array or grid array of ints. And I think where are we going to want to create that? For now, we'll create it right here, but I think we'll move it in fairly short order. This would be map. Where are we? Map. Width and map height. So what we're going to want to do is pass in so that'll be good. I need to double check my calling conventions for passing a two-dimensional array. I believe I do it elsewhere, so I believe some of my console functions may do it. So let's look those up. And again, this is shaking off the rust of the old brain here with regards to C. Console. So console has pixels, and I treat this as a two-dimensional array. Let me look at this. Okay, so I'm just doing it dynamically here. I'm allocating that much space. And then where do I start treating it as an array? Oh, I'm just doing pixel calculations here. Okay. Or the offset calculations. Well, let's see what happens. Let's just do a quick test and see we can do. So we're setting this to, we're building this on the stack.
Look out of the window with all my
And then passing it in.
but I'll find
Or if we can treat this like so.
and fall apart. Maybe we can be something new. Are you ready for us? 'Cause I'm ready for you. Are you ready for us?
It's got to be a pointer.
Something new. Are you ready for us? 'Cause I'm ready for you.
Let's consult the book.
To be something new. We'll follow where the wind blows.
It may be the way that I'm doing it, and the other is the way that it has to be. It'd just be nice if there were a more convenient way to do it.
Taking the sights. Maybe we can be something new. Are you ready for us? 'Cause I'm ready for you. Are you ready for us? We can be something new. Are you ready for us? 'Cause I'm ready for you. Are you ready for us? To be something new.
So, multi-dimensional array.
Slipping off slowly, so hold
We're declaring that on the stack. That's not helpful.
honesty. Slipping off slowly, so hold
And then pointer representations.
Are you ready for us? 'Cause I'm ready for you. Are you ready for us? We can be something.
Name of an array is converted to a pointer to the first element of the array.
'Cause I'm ready for you, ready for you. Are you ready for us? We can be something new. Are you ready for us?
I wonder if that works for multi-dimensional.
We can be something new. Are you ready for us? Are you ready for we can be something new.
Let's give it a quick test. Let's do set it R11 equal to.
Despite the wall in my head, said hello to you. You didn't notice my eyes. They were chasing yours all around the room.
I don't think this is going to compile, but
All around the room. I used to be in love with heartbreak, but now I need drugs to
sometimes you gotta experiment
I used to
and
want
figure stuff out.
my love from you.
Different array subscripts. So it's looking at a
Used to be in love with heartbreak and internal fire.
Now
Those burning fires
so
fuel my desire for you.
interesting. It already knows how big so I don't think you can do this. Now it's warning. It's a warning. It's not an error. It's saying pointer to 40.
Become smoke and mirror, smoke and mirror. Smoke and mirror, smoke and mirror. I used to be in love with heartbreak and internal fires. Now those burning fires
So it sees. Okay. If I look at this bit, this is the pointer. I'm going to consult the Googles. Watch along. Let's see. So, Googled 2D, passing 2D array in C, and it looks like maybe I just need the double star. Declare the function like that. So I need the, yeah, it decays into pointers once, not recursively. So I need to give it the second. Yeah, we were close. So it looks like what we need is this. Because this, and we could even see it in the warning here. It converts that first dimension into the pointer automatically, because the first the name of an array is essentially a pointer to its first element. So let's see if this will do it. All right, save this. Different array subscripts. It's even. There or not. That's the problem, I think. It's not now, the problem is the way I'm calling it. So, no, I'm only passing the name. Maybe that's what I don't pass the address. Okay, it seems to like that. So let's just double check before we build a bunch of stuff on top of that. Let's check and make sure that it's behaving like we think it is. So I'm going to temporarily move this code, and I'm going to move it to right before we, I'm going to move it into our debug right here, so that I can set a breakpoint on it and trip it. So build, run, and then what we're going to do is we're going to fire up our Visual Studio and set a breakpoint. show that to folks out there. Okay. So next we're going to open up our game file so we can set a breakpoint in it. Not the game file. That's not what we want to open at all. That's dark. That's our main file. And so right now we're just looping through our game loop. So I'm going to put a breakpoint here so we can step in when I hit the M key to trigger this code. Where's my game? So I'm hitting it now, and we hit our breakpoint. And so now we've got our FOV map, which has a lot of rows and columns. And let's step into... step over, that's no good. Let's keep going. Loop around again. Gotta hit the M button again, because fat fingered the debug. Okay, we're back in. We want to step into the code. And here's our FOV map. We're going to set the 1-1 item to the value 10. And then we're leaving. So out here, step one further, and then we can see FOV map. And then we want to look at the 1-1 position. And we get 10. Voila. All right, so we are able to write into that memory just fine. Let's, just for giggles, make sure that like the default value isn't 10 or something ridiculous like that. So, okay, yeah, it looked like it had initialized everything to 0. So, all right, so that is excellent. Kill our game, and we've now determined that we can successfully access our two-dimensional array here by using the brackets that we want. So we'll move this code out of our debug and back up to its actual position. Okay. So what we're going to want to do for our field of view calculation, the first step again is going to be initialize to a known state, because we'll be calling this multiple times, and so we want to reset everything to a default state. And now, is our default state visible or invisible? And I think it's just got to be... I think it's got to be invisible. So we're going to set our default state to 0. And I know that there are shortcuts for clearing and for zeroing out memory, especially when dealing with like a two-dimensional array and that sort of thing with pointer arithmetic, but I'm going to go for the readability of code at this point, since this is kind of a learning project. So at this point we're going to set our map at XY, set it to 0. That'll get us into a known state. So let's write some pseudocode for what we're thinking about doing. Close this. Okay. So we said that our initial algorithm is going to be, if you're in a room, you can see that entire room, and basically nothing else. Yeah. And then maybe... No, we're not going to have rules for... So we'll need to figure out what the rule for corridors is. Because if you enter a corridor and maybe we'll implement a similar rule where if you're in a corridor, you can see everything in that corridor. Okay, so... we don't actually have a list of our rooms anymore. So how are we going to figure out if someone's in a room? Maybe we simplify the algorithm even further for our first pass, and we say that we're just going to be able to see 8 squares in every direction. 8 squares in the 4 primary directions. So you'd basically have a big square of visibility that following you. It'd be the weirdest torch ever. It casts light in a square fashion. But at least that would give us the sense of a field of vision, and it would allow us to start marking our map as things that we've seen and things that we haven't seen. Because the way that it's going to work is if you've seen something, like if you've seen a wall or a room or whatnot, but that you're not in that room or you're not near that particular thing, it will still appear dimmed out on your game map. The exception being monsters. So monsters, if they are not in your sight, you cannot see them. Unless you've got some kind of magic that lets you see them. But even a simplified FOV algorithm will let us start putting together those game mechanics. So what we're going to do is, cast visibility out in 4 directions. and then we're essentially going to mark things as visible within our visibility distance. So we'll define a distance. We'll just call it FOV distance. And right now we'll make it 8. Seems reasonable with the size of our map. Maybe we'll see if that's, we'll test it out. We'll see if it's too big, too small. All right, so we're gonna generate a rectangle around our, well, okay, so maybe 8 is too far, because if we're casting it at 8 in each direction, that's pretty stinking far. That's like 16 by 16. Let's rate it and we'll call it 5 for now. So we'll say that our x1 is equal to our x minus we can't, I was going to say if then have a test for negativity, but we're using an unsigned int, so that would be a bad test to perform on that. Let's just keep going. X2, X plus FOV distance. And then we'll similarly do things in the Y direction. Y minus FOV distance and 2 equals Y plus FOV distance. So we need to protect our numbers from going negative because they're unsigned ints. And when unsigned ints go negative, bad things happen. As we found out the other night. So we'll say that if x is greater than our FOV distance, you can say greater than or equal to, we'll do that math. Otherwise, we'll set it to 0. Let's do this. Because otherwise you run into scoping issues. Okay. And we'll do that, and then let's declare our I2, I1, and then if okay, now the other thing that we need to test against is we need to make sure that we're not going off the right or bottom edges of our map. So we need another check. If x2 is greater than or equal index. Remember, we're starting at 0, so we need to index to start at 0. So map width. Then we're going to set x2 equal to our map width minus 1. So that'll be the greatest index in our array. And we can similarly collapse this to a one-liner just to save some vertical space, make the function as a whole a bit more scannable. So this will be if y2 is greater than or equal to map height. We will set y2 equal to our map height minus 1. And then we draw our visibility, or apply. We'll apply the visibility to our field of view map, and fx is going to be our x1. Our starting condition is our x1. We're going to loop until while we are less than or equal to our x2. And similarly, our fy is going to be initialized to our y1, and we're going to, man, I'm getting a little tired, as you can see. I left my increment out. So our fy is less than or equal to our y2. We're going to increment. And what we're doing is we're going to set our FOV map, fx, fy, to full visibility, which in our case is going to be 10 now, I guess. It's kind of an arbitrary value for now. We'll have to dial that in a little bit, but it works for now. Great, and then we're done. So we've got our FOV map at that point. We need to apply that somehow when we render our screen. I'll look and see visibility. So I think I want to add another item to our visibility component. Right now we have our object ID, the glyph that we're supposed to be showing, and then a foreground and background color, but I think we should build in the aspect of our field of view calculation. So that's something we really want to be a property of the object itself. So right now, this is our render screen function. Basically what we're doing is we are looping through all of our visible components, and we're saying, okay, give me the object that's related to this component and tell me its position, and then put the glyph for this particular object at its position with its proper foreground and background color. So I suppose we could, yeah, I think that works if we make our FOV factor I think if we have that factor in. If you guys and gals give me 1 second, I'm going to take a quick break and we'll come back and bang that out and then be done for the evening. But I'm going to take a quick break and I will be back in like 2 minutes. Okay, I'm back. Thanks for waiting. Family duties called for a moment, so let's finish our FOV, or our first pass at FOV, and then we will, I think, call it an evening. So I'm going to add a, it can be an unsigned 8-bit integer because we're not gonna need that many values or that big of a range of values. So let's call it, hey, Gun Games, good to see you. How's it going? Let's call this FOV. I guess we could just call it FOV site. I don't know. I'll just call it FOV for now because a better name is escaping me. So, I'm just thinking, is this the best way to do? I'm just thinking about how I might apply my calculated FOV map to my objects. Seems to me like it would be rather inefficient to map that data to my world state. It should really act more as a lookup that I do last minute. I think I'm gonna not have it be part of the visibility. And have it. So I'm gonna need to make FOV, our FOV map more of a global. And I'm gonna move it in here, which makes sense. So I'm going to declare this now at the global scope. Much like we did with our world state.
Every man has his own ambition.
And so what we're going to do then, we've calculated our FOV map. We're going to apply it in our render. So in this loop, we can add a condition, basically, that says we'll get the position, and before we just, blindly, no pun intended. Before we just blindly write everything to the screen, or to the console, we're going to want to check and see if that thing is actually visible, according to our field division. So we're going to say if our FOV map PX, PY, is that what we got going on here? PX, PY. If our map at that point indicates that something is visible, which we'll just for now say any value greater than 0 is at least partially visible. And we're not going to handle different degrees of visibility at this point, but so now we've added the condition that it needs to be designated as something that's visual in our field of view map. I don't do any error checking on initializing SDL or creating your window. Yeah, I know. I can add all that stuff in. I assume that if my SDL window isn't created, I've got bigger problems. So I could add a bunch of error checking here, and but essentially, if I've bombed out here, then the game's just not going to start. But yes, it is. I should probably get in the habit of error checking all of my SDL calls. The fact of the matter is there really aren't that many of them that I'm making, so I should probably just go ahead and do that. Maybe we'll throw that in as a task on our refactoring pass. Okay, so I think we have calculated our field of view immediately after we position the player in the level, which we've generated. However, field of view is it's dynamic. It has to move with the player. So that's obviously, let's see. So what we need to do is we're going to need to recalculate it at some point. I've run out of music on this playlist. Oh my goodness. What happened here? Let's throw another one in. All right. We're going to want to recalculate our field of view when our player moves. So we're going to need a flag that will tell us to recalculate. Maybe we should just test this first. Test what we got before we even try and move. Sure, let's do that. Okay, that looks reasonable. It's positioned our player, and it's drawn the stuff that is immediately around him. So that's pretty cool. That's excellent. All right. So the next step is to build in the thanks. Where do we want to declare? So while we're not done, we're looping. We are going to want another bool in here that says FOV, set that to false initially. However, if our player moves in any direction, we are going to want to recalculate that. So this would be if our player can move and did move, which means we're reapplying the new position into the player's position component. Recalculate FOV becomes true. And we need that for the up direction, down direction, left and right directions. So when we get down, right before we render the screen, we need to check and see if we're recalculating our FOV, or if we've been asked to recalculate it, and if so, well, hey, let's recalculate it. And clear our flag. And again, we are passing in our we do have player here. We're sending in our player X and Y. Oh, we need to get our position. And then sending in our map, which, since it's global right now, is not necessary. What text editor am I using? I'm using Sublime Text, which I like very much, and I like the fact that it's available on Windows and Mac. And it's got a bunch of plugins that you can, or freely available plugins that you can install for syntax highlighting of any language you can think of. There's various, it's completely, you can write your own plugins in I think it uses Python to do the scripting inside the text editor, so you can extend it to your heart's desire. So I need to grab the game object, get component, and I get it from player, and I want my component position. And then I'm going to pass that in, the X and Y, and then my FOV map. To the recalculate function. Just use Visual Studio. Yeah. And I would probably do the same thing if I was always coding in Windows, but I prefer a tool that you know, I can use the cross-platform and learn one set of rules and one set of environment. Of course, the key bindings are completely different because Control versus Command keys, so I'm constantly trying to hit Command when I mean Control, and vice versa. Use Vim, yeah. I never taught myself Vim. I've tried a couple times to read through the docs and mess around with it, and I just have never put in the time to learn all of the various key bindings for Vim. Okay, so I think we're there. Nope, we got a problem. Oh, unresolved external. FOV recalculate. In my main, huh? Did I fat finger it? Oh, wait a minute. No, referencing it up there, so it's brought in ahead of time. Where is it? It's not giving me a line number now, that would be too easy. Oh, it's a linker error, okay. U32. Oh, no, the warning, yeah, it's complaining about the main. I can go ahead and make it the standard C main. Yeah. Yep. Alright, yeah. Link. But it's complaining about something different. Wait a minute. Is that... I'm going to leave this as is for now because the way that the SDL like redefines main. But it's complaining that FOV recalculate. Which is interesting because it didn't complain when it was just here. Do I have the right? Oh, it's not recalculate, it's just calculate. I'm recalculating it. Oh, did I? Let's see. Excellent. No warnings, no errors. Thank you, stream. Thank you, chat. Alright, so let's see what happens. Alright, so now when we move, our field of vision should move with us. Oh, look at that. That is all sorts of fancy. Woo! Coolness. I like that. Alright. I think I am gonna call that victory for this evening. And call it a night because I've been streaming for 2 hours and my brain is now approaching the realm of sleep. But just to recap what we did tonight, we created over here in our game. We created our level initialization function, which we started out by clearing the previous level data from the world state, and hey, Gun Games, cheers. Then we generated the level map into that state and placed the player in a random position on the map. So I should say in a random, not necessarily a room, random position within the level. And then we started working on the initial implementation of our field of view code. And we basically defined a very simple algorithm to start with. We are basically just casting light in the 4 primary directions in a box around the player, and integrating that into our render function so that we only render things that are both visible and within our cube of light or square of light. So next steps will be to implement the idea of remembering where we've been and still rendering rooms and places that we visited. We're still going to render those to the game map, so that we can remember where we've been. And yeah, and then I think then we can enhance our FOV algorithm to be an actual kind of sphere of light surrounding us. Have it be a little bit smarter about things that are obstructed, like we're not going to be able to see through walls, that sort of thing. And I'm still working on that kind of algorithm. I got my notebook right here, and I've been thinking about that. We're going to do the shadow casting algorithm that is used by a lot of 2D games. It's a pretty efficient 2D algorithm. I'm still trying to wrap my head around that. But I think that'll do it for this evening. So I thank you for watching. Archives on YouTube if you're interested in seeing old episodes. Questions or comments, hit me up on Twitter at PDCodes. You can grab the source code from GitHub. I'll be updating it momentarily. And if you want to get notified the next time I'm streaming, then hit that follow button. So I appreciate you watching. Good night.